All right, so a few more equations that we want to solve. Notice in number 17 here we have some parentheses, so our first move is going to be to get rid of those parentheses so we can start simplifying and combining things. In this case, I'm going to do 3 times 2x, which gives me 6x, and then I'm going to do 3 times 4, which is going to give me a plus 12. I still have a minus 5 on that side of the equation and a 6 plus 11 on the other side. Now I have something with no parentheses. On the left side, there are some like terms, and so we can go ahead and put them together because they're on the same side of the equation, so they're friends. 12 minus 5 gives me 7. And so now I have 6x plus 7 equals 6x plus 11. Well, the next thing I need to do, I've got x's on both sides of the equation. That's a problem. And so I need to get them onto the same side of the equation so that I can actually put them together. And again, I need to have just a plain x by itself so that I can solve this equation. So if this is a positive 6x, it's going to need to do a minus 6x to move it over to the other side. And if you do it to one side, you have to do it to the other side. Now at this point, you may be recognizing that some strange things are happening. On the left-hand side, I get 6x minus 6x, which I needed to do to get it to move over to the other side, and I was left with 7. But on the right-hand side, I also ended up with 6x minus 6x, and my x's are gone altogether from the equation, and all I'm left with is 11. So something really weird happened here. And this does sometimes happen when we try to solve equations. It's not necessarily the most common case, but it is a special case, and you should know what it means when this happens. In this case, what we did, we were trying to solve for x. The x disappeared from the equation, and most importantly, I'm left with something right here that says 7 is equal to 11. Well, that's totally false. It's never true. And so what this means is that I have no solution to this equation. Sometimes for no solution, you'll see this symbol, and that means that there is no solution to this particular problem. What that means is it doesn't matter what number you pick for x, you will never, ever, ever get this equation to be true. All right, so kind of getting ready for something weird with problem number 18. So I've got a 2/3 outside the parentheses, so I need to distribute that through. Keep in mind I'm going to be multiplying some fractions here, so you might want to think of this as 6 over 1 and 12, or 6x over 1 and 12 over 1 when you do those multiplications. Here I'm going to do 2/3 times 6x. I can do a little bit of reducing there, and when I'm done, I should end up with 4x. Then I'm going to do 2/3 times minus 12. Again, we end up with 24 over 3, which is 8. So fortunately, I got rid of the fractions when I was multiplying just because things went in nicely. That doesn't always happen. On the other side of the equation, I have 4x minus 8. Again, we've got x's on both sides of the equation, so we want to put them together on the same side. In order to cross over the equal sign, we have to add or subtract to move it. So in this case, I'm going to minus 4x from each side. When I minus 4x here, it goes away, and I'm left with negative 8. On the other side, when I minus 4x, same thing happens here. It went away, but this time I'm left with negative 8 on the right-hand side as well. Now, in this case, negative 8 is equal to negative 8. This is true. What that means, when the x's drop out of the equation as part of the solving process, and what I'm left with is no variables but a true equation, that means it doesn't matter what x was, it's always going to work. So in this particular case, all values for x will work. All values for x will be solutions for this system. Another way that you may see this written is like this, and what this means is it's a symbol for all real numbers. That means you could put any number in here for x you want. You could put in 0 and it'll work. You could put in 5 and it'll work. You can put in negative 4,612 and it will work. You can put in pi and it will work. It doesn't matter. Any number that you pick for x is going to work because eventually the x doesn't have any impact in the problem. It drops out and you're left with something that's always going to be true. So this does sometimes happen. These are special cases that do sometimes appear. Because of these special cases, we do have some terms about equations. And so a couple of definitions that you may want to use sometimes when you're referring to these. The first type of equation is the conditional equation. And what this means is that your equation is sometimes true for just particular values. This is what usually happens. You go to solve for x and you end up with x equals 5, or you go to solve for x and you get x equals 7. You're able to get that variable by itself, and you get very specific values that do work in the equation and make it true. So when we're working with linear equations, there's one solution that we end up getting. In the case where we end up having our variables drop out and we end up with something false where there's no solution, we call that an inconsistent equation. This is our no solution case. There's no solution for the equation. There's something wrong with it. What we're left with when we try to solve, nothing will work. No answer will possibly work. The other type of equation that we sometimes get is called the identity equation, and this is the all real numbers are a solution for our equation. And again, that happens when you try to solve the variables drop out, but you're left with something that's true, which means no matter what variable that you pick, it will always work. All real numbers are solutions. So these are the specific vocabulary terms. If you have a conditional equation, usually just giving your answer is enough. But if the variables drop out, it's really important to specify which of these particular cases you have. If it's an inconsistent equation with no solution, or if it's an identity equation where all values of x or whatever your variable are will work.